All right, everybody, welcome here. Quick video on just some basic stoichiometry. So we're just going to talk about basic stoichiometry problems. We're not going to talk about limiting reagents in this video. Maybe I'll have a second follow-up about limiting reagent type problems, but just basic stoichiometry. So what is stoichiometry? Sometimes people get all confused and worried about stoichiometry, but it's really just a conversion factor. And we get the conversion factor actually from the balance equation. So if we had our equation like this one here, and of course with any equation we always want to make sure it's balanced, so we'll do a 3 right there, I think. And now we have a balanced equation, and from this balanced equation we could look at the coefficients from the balanced equation. And the coefficients from the balanced equations is what is sometimes referred to as the mole-to-mole relationship. Now, where we get this relationship is really just the coefficients. So from this equation, we could say for every 1 mole of N2 that we put in there, and again, there's no number written there, so it's assumed to be a 1, we would also put in there 3 moles of hydrogen. And again, the 3 is the coefficient here. We could also say for every 1 mole of N2 we put in there, we get out 2 moles of NH3. We could also say for every 3 moles of H2 we put in there, we get out 2 moles of NH3. So from this one equation, we get 3 equalities, and these are sometimes referred to as stoichiometric equalities, fancy word. But they're really like equalities like when you're doing just basic conversions and conversion factors. So from any equality, as you probably remember, you could write 2 conversion factors. So for example, I could write 1 mole of N2 over 3 moles of H2. Or I could write 3 moles of H2 over 1 mole of N2. For this equality, I could write 2 conversion factors. I could write 1 mole of N2 over 2 moles of NH3, or 2 moles of NH3 over 1 mole of N2. For this guy right here, I could write 3 moles of H2 over 2 moles of NH3. Or I could write 2 moles of NH3 over 3 moles of H2. So from this one equation, we get 6 conversion factors. Now, do we use all of these conversion factors in a problem? Heck no. You're probably just going to use 1, but you have available to you 6 of them. So this is what stoichiometry is. It's a conversion factor that you get from the equation instead of like looking it up in a table. So why do we have to do that? So for example, we may be given some information, say about anybody in this equation. Maybe we got some information about H2, and maybe we want to know how much product we would produce. So we need a way to go from H2 to NH3 in this case, and that's what stoichiometry allows us to do. Or maybe we have information about H2 and we want to know how much N2 we would need to put in there with it. So we need a way to go from H2 to N2, and we use the equation as a conversion factor. So let's see how that would work. So we'll take our same equation here, our N2 plus our H2, giving us our NH3. And again, a little balancing there and a 3 there. Now, when you do basic stoichiometry problems, there's really 4 steps that you want to follow. Step number 1, you want to make sure that you balance the equation. None of this works in terms of stoichiometry if your equation is not balanced. So always, never hurts. One more time, always make sure your equation is balanced. The second thing you want to do is take whatever they gave you, whatever piece of information they gave you, and in a basic stoichiometry problem, you probably only be given one actual number or piece of information. You want to take that number and convert it to grams. And once you have it in grams, you then want to convert it to moles. So it may require you to do a couple of conversions to get to grams, but you ultimately want to get to grams and then convert it to moles. As you may remember from a previous video, that we'll put a little link up there to go from grams to moles. That's going to be your molar mass from the periodic table. That's going to allow you to do that. Remember, molar mass is grams per mole. So that is what you get from the periodic table. You can use that as a conversion factor. Step number 3 is the actual stoichiometry step, the mole to mole relationship from the balanced equation. You're going to find the 2 things you're interested in. Like, for example, 1 mole of N2 is 3 moles of H2. And you're going to use that as a conversion factor, for example, to go from, say, N2 to H2, or H2 to N2 in this example. Lastly, you will always be in units of moles on the 4th step. And a lot of times you do need to convert it to some other unit, like grams. So sometimes on the back end here, we're going to use the molar mass one more time. All basic stoichiometry problems are these 4 steps. You should always do them in order. You should skip a step if it's done for you, but you should never go backwards. So you should always go forward when you do these steps. So let's just say, for example, we started with 22 grams of H2, and we want to know how many grams of NH3 would we produce. So we're going to follow our 4 steps here in the stoichiometry problem. So step number 1, balance the equation. That is already done for us, so we're good. Step number 2, take whatever they gave us and convert it to grams to moles. So we do have grams. We do need to convert to moles. So we do need to do step number 2 here. Or to do step number 2, I need to go to the periodic table, find hydrogen, find the molar mass from the periodic table, which is this number at the bottom. That means the molar mass of hydrogen is 1.008 grams per mole, but it is actually H2 here. So to find the proper molar mass, we do need to multiply this by 2, and we will get our molar mass here. Let me just write it a little better of a way. So get rid of that right there. So to get it, we will go 2 times 1.008 grams per mole. And that's going to give us 2.016 grams per mole is the molar mass of H2. We are going to use that as a conversion factor. So we'll start with what was given to us, 22.0 grams of H2. Again, dimensional analysis is the way to go. So we'll put it over 1. That tells us grams are up on top. So to get rid of grams, we're going to go to the bottom here, third molar mass. Remember, the number always stays with the grams part, and it's always per 1 mole. Here we're going to multiply and again divide. And when we do that, the grams of H2 will cancel. And if you get a number at this point, you will get 22 divided by 2.016. It's going to get you 10.913. I won't round too much, moles of H2. So that is step number 1. That is step number 2. Now we're off to step number 3, which is the mole to mole relationship. So once again, we are not interested in the H2, which is what we were given. We want to get over to my NH3. So this is where the equation in stoichiometry comes into play. We're going to use the equation as a conversion factor. So I'm definitely interested in H2 because that's what I got. So for step number 3, that would tell me 3 moles of H2. And we can see from the equation, we have 2 moles of NH3. That again is going to get us 2 conversion factors that we could use. 3 moles of H2 and 2 moles of NH3 are, we could flip it around, 2 moles of NH3 over 3 moles of H2. So taking our number from the previous step, 10.913 moles of H2, again, just taking a dimensional analysis approach, moles of H2 are up on top, opposites cancel. We need the conversion factor right here, and that would give us 2 moles of NH3 up on top, 3 moles of H2 on the bottom. Once again, we are multiplying the top, dividing the bottom. The moles of H2 cancel. So we're going to take our 10.913, we're going to times it by 2, divide it by 3. Going to get us 7.275 moles of NH3. Now, we're off to step number 4 because we are looking for grams of NH3, not moles. That's going to require the molar mass again, but at this point, we are at NH3, which means we need to go back to the periodic table, find nitrogen, which is 1401. We also have our hydrogen for the periodic table. And to get the molar mass of NH3, we're going to add up all the parts. So nitrogen is 1401 grams per mole. Plus there are 3 hydrogens at 1.008 grams per mole. And if we add all that together, 3 times 1.008 plus 1401 gives us a molar mass of NH3 of 17.03 grams per mole. So remember again, when you're calculating molar mass for either of these things or anything in an equation, it is based only on the formula, not the coefficient. So we don't use that when we're doing molar mass because it's per 1 mole. We're going to use that as a conversion factor here. And again, at this point, moles of NH3 are up on top, which means the moles of NH3 need to go on the bottom. The number always stays with the grams part, which in this case will go up on top. And again, we're going to multiply and now divide. We'll take our 1703, we will times it by our 7.275 and hit equals. And that will get us something like 124 grams of NH3. And that would be step number 4 here. So you can see here 4 basic steps for a basic stoichiometry problem. Balance the equation, convert to moles using the molar mass from the periodic table, go to the equation, get the mole to mole relationship for what you're interested in, and then take those moles to some other unit. What does this number represent? This number represents if you did this reaction, everything went perfect, you threw in there 22.0 grams of H2. In theory, you should get out 124 grams of NH3. That is what is known as the theoretical yield. Let's try to squeeze it in there. That is the theoretical yield, which is your maximum yield. If everything went perfect, that is what you should get out. Now, if we look at this equation again, couple of things here. Now, sometimes people think that you do need to always kind of go across the arrow to do stoichiometry, like you always have to go like this way. And that's true. You can do that. You could also go this way. You could also stay on one side of the arrow and do stoichiometry calculations. If you had two products, which you don't in this case, but if you did, you could also stay on that side. So for example, if I had 20 grams of N2 and I want to know how many grams of H2 would I get or need to react with it, I would do the same 4 steps, which is balance the equation. That is done. I would convert what they gave me into moles. And that I do need to do. So I go 20 grams of N2. I would again go to periodic table, look up nitrogen, 1401. That is 1401 grams per mole. It is N2 in this case, which means the molar mass should be 2 times 1401 grams per mole for my N2. And that would give me a molar mass here of 2802. We will use that as a conversion factor. Again, we got to go grams on the bottom so that they cancel. Again, multiplying, then dividing. The grams are going to cancel, and we will end up with here 20 divided by 28.02, 0.7138 moles of N2. Step number 3 is our mole to mole relationship. So going to the equation, that is this guy and this guy. That's step number 2 there. Step number 3, we can see from the equation 1 mole of N2, which is the coefficient, will give us 3 moles of H2, which is its coefficient. We're going to use that as a conversion factor like I've been talking about. So 0.7138 moles of N2. Opposites cancel, which means moles of N2 on the bottom and 3 moles of H2 up on top. These are going to cancel, multiply, divide. Going to take times out by 3. We'll get a 2.141 moles of H2. Last step is step number 4. We're going to take those units to grams, for example. So we need the molar mass again of H2. We calculated previously 2.016 grams of H2 per mole of H2. That again comes from the periodic table, 1.008. You need to times it by 2 because it's H2. And the moles here are going to cancel. And we'll divide it by, we're going to multiply it, multiply by 2.016. Going to get us 4.32 grams of H2. So in this reaction, if we wanted to react 20 grams of nitrogen, we would have to put in there about 4.32 grams of hydrogen to react with it. So you could do stoichiometry on the reactant side between two reactants. You could do stoichiometry between two products on the product side. You could do stoichiometry between reactants to products or products to reactants. So you can do it with anybody in the equation. Last little thing that ties with this is if we look back at our original problem there, we produced 124 grams. And that 124 grams that we produced of NH3 was known as the theoretical yield, and that is your maximum yield. Again, it is basically how much you should produce if everything went perfect. There is what is known as the actual yield, which is when you do the experiment, it is actually how much product you made. As you might know, things don't always go perfect. And that's what theoretical yield sort of banks on, is everything's going to be perfect. Nothing side reaction is going to happen. You didn't spill anything. But actually you probably will get less than that. So there is a relationship known as the percent yield, which is the actual yield divided by the theoretical yield times 100%. So let's just say, for example, we did this experiment and we produced 111 grams of NH3. And we want to know what the percent yield. So percent yield would then be our actual, which is how much we actually produced in a experiment. And most of the time that would be given to you in a problem, divided by the theoretical, which most of the time you would calculate, like we did in the first example, 124. You get times it by 100%. Now you can use grams over grams here. You could also do moles over moles. As long as they're the same unit, you could do it. But we're going to use grams as grams. So 111 divided by 124 times 100 gives us a percent yield of 89.5%. Not bad. So usually on percent yield, you want high percent yield. You usually don't want above 100, because that usually means something didn't go maybe so right. But close to 100 is good, and the 90 is definitely really good. But you definitely don't want a really low percent yield. If you got like a percent yield of 2, you did something not so great in the experiment. All right, that was a quick video on basic stoichiometry only. No living reagents in this one, and a little bit about percent yield. I hope it helps. We'll see you on the next one. Bye-bye.